Anyone, please? Good evening, everyone. We will wait for some 5 minutes, then we'll start the session. Good evening, everyone. Shall we start the session? Anyone, please respond. Shall we start or will wait for some 5 more minutes to join others? Please, anyone tell like my voice is audible or not?
It's audible.
Okay, thank you.
It's audible.
Shall we start the session? Before starting the session, I would like to tell you what is the reference book that you can go through that.
Yubi, वो book किधर ला बेटा?
Shall I go ahead with that? Reference book that I will tell you.
ये दरवाजा
Please,
नजदीक लगा.
please put the mic on mute. Okay. Good evening, everyone. Whether my screen is visible?
Yes, it is.
Okay. So, good evening, everyone. And my name is Asjid Raza. And today I'm going to take second week session, like a live session for the course of Biostatistic and Design of Experiment. And just 1 minute. Someone wants to join. Okay, so today will be that second week for the live session, and actually till last week it was that open to all, and we got the instruction from the NPTEL team that there should be a host control for that, or that the person who is that handling the session, they have to manage it. So that's what I'm compelled to do. So please wait for some time, 6:10 or 6:15 we'll start the session. Before that, we will just talk how many of you went through that full lecture, like for second week and first week completed? Anyone like who have completed?
Yes, sir. I completed the first week and second week. Actually.
Okay. Any doubt is there, like a specific doubts?
Yes, sir. Matlab, in solving the questions, I am get stuck in between. So again and again, I am watching the videos to learn more.
Okay, ma'am. We'll do one thing. We will solve some questions also, and I will tell you some books. If you go through that, it will be very helpful. That can be for your solving the examples, and I will solve also some problem today also. Somewhere 10 question based upon the normal distribution, then t-test, then maybe sometime Poisson distributions also. Okay, and
Yes, sir.
I, according to the course, that professor, that I will recommend you the book. I'll show you just this book. You might have seen that. That's the one book that a statistic, a guide to a statistical method in the physical science by R.J. Barlow. I will just write in the chat box. by RJ Barlow. This will be specific to that like design of experiment and design of experiment and that biostatistic part. But if you want to get more basics and basics, so I will that suggest you one book, that fundamental of statistical mathematical statistic. It's that Gupta and Kapoor books is there. So I will show you that book also. This book only. Fundamental of Mathematical Statistics, that is the S.C. Gupta and then V.K. Kapoor. So this book will be like more than good. You can solve all the problem. By S.C. Gupta and V.K. Kapoor. This second book and that all book you can get the online also. Like I will not tell the website because it's a forbidden. But you might be knowing that all the website that you will get the free book. Okay. So personally, I will refer that one, that fundamental of mathematical statistics for this lecture and all. So yesterday we have went till binomial distribution, and then somewhere around Poisson distribution we have solved some questions also. Is it?
Yes,
Yeah,
sir.
yeah.
So today we'll start from some Poisson distribution question. Then we'll discuss like normal distribution, and normal distribution we will see that how we can see the tables, Z values we can find out to find out that probability. You might like some people might have like some difficulties to how to see the tables. Anyone is there? Like sometime we will stuck at some point, like will not able to see that, we are not able to understand that how we can see the tables.
So
Anyone is there?
tables is easy to understand, but the only thing is when to apply, like when to subtract and when to add the area. Like for example, 0.5 minus something, we have to do like based on the means.
Okay. Yeah,
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 yeah.
that
Those
at
kind of
that I will.
confusions.
Uh-huh.
Yeah, yeah. That is very important. I understand. Like based on the question, we have to understand first clearly, then only we can solve it easily.
Yeah,
Otherwise,
sure.
difficult.
Yeah, yeah. That thing hopefully today we'll discuss. We'll do some problem based upon that also.
Okay.
Okay, so I'll go to the PPT. Like we have attendance till now 30. So 2 is me. 21 attendance is there. 28. Okay, so this book, like if you went through the lecture, so you might have seen this book like in the reference. Sir might have told like a guide to the use of a statistical method in the physical science, and for solving all the like test that test significance and the normal distribution problems. So we will be having some Fisher test or tables will be there. So that table I will be showing also, and then we'll do some problem based upon the normal distribution. And before starting to the session, I will be just briefing binomial distribution that I have already discussed. Like, but we'll see like a random variable x is set to a follow binomial distribution if it assumes only a non-negative value, and its probability mass function is given by like this, like NCR and then p to the power x q to the power n minus x. Okay, so where n is the number of trials or the number being sampled. Is it getting repeating, or shall I go ahead with that problem? Like we have done some problem na? Yeah, last week.
Yes, yes. We are almost clear on this.
Okay, okay. So I'll just do some like then Poisson distribution. That's also hopefully it will be that cleared. again, like if we define like a random variable x is said to follow a Poisson distribution if it is assumes only non-negative value. Whenever we are going to define, so we have to define like their limitations also when we'll see like this. So we have to define the in terms of limits also. Then after we'll say okay, what is the probability mass function for that? So lambda to the power x e to the power minus lambda and then x factorial. So if we say lambda is equal to just nothing like np. Anyone have the idea like when we have to apply the binomial distribution and then when we have to apply Poisson Poisson distribution?
In binomial distribution, it is like number of successes, number of outputs will be two, like only two.
Okay.
But in Poisson, it is like events, not successes, but it is, we can say it as events. So it can be more than two also.
Any other?
When the sample size will be larger, then we should use the Poisson, and sample size smaller, then we will use binomial. Is that?
Yeah.
When the
Anyone?
sample size is n numbers, then we will use the Poisson, and when the number size is small, then we will use the binomial.
Okay, fine. Like let's say we have a example. In family, we have the member around some 10, 12 will be there. So there we can use like and there that the chances of occurrence it will be more, or somewhere it will be less also. Somewhere it will be less also. So there will be no issue with that. But we will be having overall size will be the always less. If we say about if we say about the Poisson
Sir,
distribution.
your voice is so low.
Oh, my voice is so low. Is it okay now? Hello?
Yeah, but sometimes it is breaking also.
Okay, fine. I will try to. Okay, hopefully will now fine.
The sound is okay
Yeah,
from
yeah,
my end.
yeah, much better.
Okay, fine. Okay, so I was saying like in the case of Poisson distribution, like say we have a lot of that 1,000 product or somewhere around 1,000 or 10,000. So we will say the defective product it will be their chances of occurrence will be always less, like 5%, 2%, 10%, not more than like 70%, 80%. It's like it will be a failure for the product. Okay, so in that case, what we'll do when the chances of occurrence will be the less, like 5%. Let's say we have made some lack of product, but now they're saying okay 5% of that product are defective. So we can't say like 95% of the product defective. Okay, so we will not say like this. So in that case we will apply the Poisson's distribution. If we say like we have the sample size or population will be the less, in that case we will apply for the binomial distribution. So this is the somewhere difference we need to understand when you have to apply any of the that distribution formula or either that statistical method. So we'll go next one, like we'll solve one problem.
Sir, one question. What is the threshold number? Means upon what extent? Means after what number we can use Poisson's distribution? Is there any threshold number?
Till now there is nothing like that. Just say binomial that limiting case of binomial distribution itself a Poisson distribution. It's a both are correlated. Okay. So whenever we will try to get stuck at some point, we will not getting through the binomial, so we'll go with the Poissons. It's a binomial distribution is a like limiting case of that Poisson distribution, or either Poisson distribution is a limiting case of binomial distribution. It's both are correlated. So there is no threshold number like we'll say in terms of quantitative like a 10 or 20 or that 100, but it when we'll feel like we can't solve like that computationally. So we will say okay we'll go for that particular method.
I think, but one way we can say like in Poisson, n will be more and p will be less, small number compared to binomial.
That comparative will say. Yes, one have raised the queue that raised the hand.
Yeah, actually, in Poisson distribution, we see the number, we predict the number of events that would occur in that particular time period or in, I mean, a fixed the other city or amongst some huge number. That is what is a Poisson distribution, isn't it? In binomial, we have either yes or no, kind of distribution, isn't it?
Yeah, that we can say. Actually, the thing is like when we are saying poison, so it's like a lot or either that's already happened, and then we'll say okay that 5% of the product got defective. But the same case, if any family some diseases are there, so that's again it's a like chances of occurrence will be again sometimes will be too high, but it will be again too less. So it's like whenever the chances of probability are too high, so we'll apply for the binomial distribution. Okay.
Unlimited kind of means we cannot have a fixed.
Yeah, 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 yeah.
Yeah,
We can
yeah,
say that.
I got it.
Okay, so we will start with one problem based upon that Poisson distribution. Okay, so a car, a hire firm that one car company is there. They have the two cars which it fires out day by day. Like they can be fares by day by day. So the number of demands for a car on each day is distributed as Poisson variation with the mean 1.5. Calculate the proportion of the days on which neither car is used or some demand is refused. Can anyone solve? Like I'll wait for some 5 minutes, then I will go ahead with that. Is it okay? Like I'll wait for some 5 minutes, then I will go ahead with that. Please try to solve. I will give you some hint. Like lambda is given 1.5. Now you have to apply the conditions like neither car is used, and then second one is the some demand is refused. If anyone is ready with the answer, like you can speak out. I'll go ahead with the solving. What is the given? Like and they have already told like it's a Poisson variate, like Poisson distribution already. What is the formula for the Poisson distribution? We all know that. Let's say Px is equal to x is equal to e to the power minus lambda to the power x factorial. So now that we know the formula, now we have to put the lambda is equal to 1.5 and we have to define the condition based upon the neither car is used. Shall I start or shall I wait for some time like 2 minutes?
So start it.
Okay.
So start.
What is that? Like let's say that x demand in a day. Let's say we have a like x number of demand will be the in a day. What we can do? Like first case, neither car is used. Neither car is used means that will the x is equal to 0. So x is equal to 0. So what we'll do? P is equal to x is equal to 0. What we will going to get? A to the power 1.5 lambda to the power 0, that lambda we know the 1.5 and 0 factorial. So e to the power minus 1.5, 1 to the power 5 to the power 0, 0 factorial. It's like a e to the power minus 1.5. What is the answer we'll get? 0.2231. Just 1 minute. Okay, so now the second part is that proportion of days on which some demand is refused. When the demand is going to refused, like any car or firms they are having, like they have refused the demand. When? Because whether that both car is engaged, in that case only that firm can refuse the demand, refuse that hire.
Yeah.
So proportion of days.
X will be 2.
Yeah, it will be like x is equal to greater than 2. X is equal to greater than 2. X is equal to 2 if we put like they have that valid demands is already there. So if the x is equal to 2, so then they're not going to refuse that what we can say hiring. Only once they can refuse when the demand is going to be a more than 2. Okay. So that's why in the that is a probability. We have to check it out like how we have to define actually. Proportion of the days on which some demand is refused. Just 1 minute. Okay, so then what will the case? P is equal to x greater than 2. Okay, so means that can be written as 1 minus P x is equal to greater than or equal to 2. Shall we can we write it no? Like this? Then we can write as in the bracket P is equal to x is equal to 0, P is equal to x is equal to 1, P of x is equal to 2. That we can write it now. Is it correct?
Yes, sir.
So that you can simplify. Then can anyone tell the answer for this 1 minus what will come? For x is equal to 0, we have already 0.2231 plus, then it will come, some value will come. Then after it will come. Can anyone tell the final answer for this? Anyone got the answer? I think then we can go ahead. Next question. That last week lecture video that is available on the YouTube. So anyone want to go through that again? So you can go it. I will share the link in that. So if anyone have doubt, you can go again and then see the video. Then we'll go to the next question. What is the second question? Second question is again based upon the that is Poisson distribution. What they are saying, a manufacturer of quarter pins that 5% of his product is defective. If he sells quarter pins in boxes of 100 and guarantees that not more than 10 pin will be going to defective, what is the approximate probability that a box will fail to meet the guaranteed quality? Anyone? Like this can be done with that binomial also, but like just because of 5% probability that we can go for the Poisson's also. Please, anyone solve that? Then I will wait for some 5 minutes. Then we'll solve. What is given? I will be writing some. What is the point that is already given? What is that? N is equal to 100. Let's say P is equal to probability of a defective pins. What is that? Is equal to 5%. It will come 0.05. So what is the lambda? Lambda will be mean number of pin in a box of 100. So means lambda will become NP. What is that N? 100. What is the P? 0.05. It become 5. Please solve from the next part. It's already given, so I just wrote on that. Can anyone please give the answer? Like it will not come like in terms of equation will come, or either if you are having that what you can say scientific calculator, you can use it and get the answer for that. I will write the formula also. P is equal to x is equal to x lambda to the power x e to the power minus lambda x factorial. Okay. But they are saying like guarantee that not more than 10 pins will be the defective. It means there will be always less than 10 pins that will be defective. How we can go ahead with that? Anyone? Anyone have the idea like how we can go ahead from this? Like they have given the conditions and guarantees that not more than 100 pin will be the defective. What will be the our
X will be more than 10.
okay?
So as you have said previously said, so we need to write 1 minus P probability of X less than or equal to 10.
10. Yeah.
So we need to add X is equal to 0 plus X is equal to 1 till x is equal to 10.
10, yeah. This is how we can go. If we go to the if that there is a probability of x greater than 10, means we have to do it 11, 12, 13, 14, it will till 100. What we can do when we have the less number from either side, so we know that always the maximum probability will be the 1, not going to be more than 1. We know that. Okay. So if I want to know that what is the probability that is greater than 10 to 100, so we can do, okay, we will do 1 minus, we can get the 0 to 1. So that is the thing, like we have to use that some sort of that thought process in the probability, that is the probability and a statistic problem. So that we don't have to suffer too much, like we can get the easily answer for that. Okay. I will add the slides. What is that? Next one, it will come. Will do probability of X defective pin in a box. What will be there? P is equal to X is equal to X. So it will come, we know that we have the lambda 5 X factorial. Now what they are saying? They are saying probability that a box will fail. When it will fail? When they have the defect product of greater than 10. Will fail the guaranteed quality. When P is equal to X greater than 10. What we can do? 1 minus P of X less than or equal to 10. Can we write it now? 1 minus, how we can do, X is equal to 0 to 10. Then we can apply e to the power minus 5. X, 5 to the power X into the X factorial. Either we can take 1 minus e to the power 5, X is equal to 0 to 10, e to the power minus 5, 5 to the power X, 5 to the power X factorial. So you will get a like one series. Even you can get the answer for that. Is it okay? This question is clear now? Is it clear, this question? Shall I go ahead? Okay.
Sorry, sir. So no, sir. I have little bit doubt. Like why? Like instead of taking this, like if I take x equals to 10, or like if I put in the graph pad and if I check like when it is 11 and what will be the probability, that way also we can do. Like,
yeah, that
instead of doing why we are doing this way.
Just say like what they're saying. What they're saying, like the box that will that is going to fail when their defective product is going to be a more than 10. Okay, so once you put the X is equal to 10, so you will know that is a probability. Okay, but the thing is that they are saying like when the box will fail, like what is that is a probability they are asking. So they are checking the probability that
Okay.
So that is the effective, that value will get. But the thing is like they are asking like what is the probability when that box is going to fail. So it means they are calculating itself at the x is equal to 10 only, or like a greater than 10 only. So it's a starting point from there. Okay.
Sir, one doubt.
Okay.
Here in the last line, e to the power minus 5 is taken out from the summation, and but it is still there inside.
Oh, sorry. That we can remove it.
So essentially, sir, is it it is 1 minus the probability for the 10, right?
So when the product is going to fail, when their defect part will be the more than 10.
Yes, yes. So we are trying to find it out by 1 minus probability of 10, right?
Yeah, like it's like a till 10. So
Yeah,
uh,
got it. Yeah.
it's like whenever we'll say like this thing, so it's after the 10 it will come. Sorry for my word, that one. Like so what we're finding, whenever we'll say okay, in the lot of that 100, one will going to fail. That that pin is going to fail. So we'll put x equal to 1, then 2, 3. So we'll get to know that for 1 what is the probability, but for 2 what is the probability. So then we'll add all these things, then we'll get like till 10 what is the probability, what will come for the 11, what will come for 12. So it will be, they will give the collectively from 11 to 100. Is it okay?
Okay, sir. So how to calculate in the last line individually 1 to 10 we have to calculate and add and multiply with e to the power minus 5.
Yeah, we have to calculate.
Can we integrate here?
Yeah, if you have some other methodology, so you can apply that. Even for this, like if you went through the lecture that the sir have solved in the graph calculus, something fast will be there. One website will be there. You can get the directly answer for that.
Yeah, graph
Even
pad, yes.
graph pads. Second one is that Excel we can do also. That's also we can do it directly. Just because of this we are doing manually, so it will take time. So that's why I'm not keeping the answer here. If we are going to do like software like Excel, or either the website, or either we have the software like SPSS. Anyone have the idea about the SPSS? That is the statistics software. I will show you their interface, how it will look like. SPSS actually it is meant for only statistic only. Their IBM software is there that you can do in that this software also, and we have one Origin also. Origin lab. In that also you can do all the statistical without any doing the hands calculation. Okay. Just for learning or to understand, we are doing as of now like in a manual way. Like if you are working on a research problem, or either that something, so you will be having the data too much, like more number of data will be there. So for that case, yeah.
Still, I would agree with Mr. Banerjee, who raised the question that whether are we going to calculate the probability of all from 1 to 10. I mean, x is equal to 1, means p for x is equal to 1, p for x is equal to 2, or it is probability of 10 as you had written, and then 1 minus will come as the result of the question.
We are going to calculate for all 0 to 10 only. For if we are going to expand, let me that is the expand this one.
But sir, in exams, we will have to calculate this manually.
This type of like it will be like that much calculation will not come, but somewhere it we have to you can use that what we can say scientific calculator, virtual calculator will be there on that system itself.
Okay, sir.
Shall I expand this one?
Yeah.
Sure.
What we'll do, like we have is equal to 1 minus for a to the power 5, and we have the 5 to the power 0, 0 factorial. So it's a 4. What is the case? Like it's become e to the power 5, 5 to the power 1, 1 factorial, as it will go till e to the power 5 into 5 to the power 10 upon 10 factorial. So it will, whatever the answer you will get, somewhere this value it will be always less than 1 only. So it's like a, when we got for probability x is equal to 0, there were no defect, then x is equal to 1, there is a 1 defect, then it become when x is equal to 10. So this was 10 defects were there. Once it will cross this defect, so they are going to fail. So for that we want to know the cumulative property when it is going to fail it out, like when it will fail. Okay. Till this thing we are saying like this much probability that we are not going to fail it out. Once we'll say. Okay.
Sir, sorry to interrupt. Sir, I got your point, but point is like if you go to the question, they are asking when it will fail. So then we can take x equals to 11. Like what is the, sir? Can you get back to the question once? Like I think
This one only.
probability that a box will fail to me.
What is the approximate probability? Not asking for the absolute, that is the probability when it's going to start. It's the approximate probability that a box will fail to meet the candidate quality.
Okay, sir. Now it is clear.
Okay.
Okay, so that's why you are calculating the rest of the sample which will not fail from 1. That's why you are subtracting from 1.
Yeah, we can say.
Okay.
So we'll go to now, till now that Poisson's part is cleared. Now we'll go for the normal distribution. Normal distribution, if we say like their probability distribution formula will be that 1 by 2 sigma root 2 pi e to the power minus x minus mu whole square or 2 sigma square. Okay, so sigma square we'll call the variance, lambda is the known for the parameter. So this is like a expanded probability distribution function. We have that that is a standardized normal distribution also. Some of you went to the lecture, so you might have seen like what is that standardized, and then what is the that normal distribution. So when we are going to z is equal to x minus like it will come sigma 2 sigma. So it will become like a standard. So we'll go fill the next one. This one only, sigma only. Okay, so some of that values we will be getting, like you will be having that, we all know that what is that normal distribution when we are saying it is symmetry about a point. Okay, so when we will say like it's x is equal to mu, means mean. In the case of normal, just 1 minute. Okay, but if we are going to change to the standardized, so it's going to be a change, like for standardized normal distribution the mean will be 0, the standard deviation will be the 1, and the area under the curve will be the, what do you mean by area under the curve? How we can say like this, like what is the significance of that? Anyone tell? Area under the curve.
It is the distribution of the data, like based on the percentage. Like,
let's say we have a data set is there, but that is not the like discontinuous, but it's a continuous data. So that is going to be spread over the time, like spread over the length. So whatever the area it will come. So it's like a integration. Okay, it's like a integration. Okay. So that will say area under the curve. So it will be total area under the curve will be the always 1 itself. Okay. When we'll keep like, let's say we have some values like z is like z, if we say x minus mu by sigma. So for in that case, like it will be a at the mean point z is equal to 0. What will become, because the y x will become mu by itself, mu by sigma, it will become 0 itself. Just 1 minute. Okay. The next one will solve the problem for this. Please, anyone solve that one? What is the probability of obtaining a z value of at least 1.58? Like it's like a z already given. We don't need to calculate. It's like a z formula we have now, x minus mu by sigma. So they have already computed. It's a simple problem. I will explain with the graph also. Anyone please? What is the probability of obtaining a z value of at least 1.58? What do you mean by at least? They are asking for the probability like greater than or equal to 1.8. Is it true, or that will be the reverse case?
Yes, sir.
But they are
We
asking
have to reversely calculate.
probability of z greater than or equal to 1.58. Is it correct now?
Yes, sir. Yes, sir. Correct. Sir.
Yes,
So what we'll
yes,
do?
sir.
We have that some table will be there. Anyone like, shall I show you some tables like how we can calculate? Like, let's say I'll show you that based upon the table only. Uh, this we have like this. This will be 0. It will be plus 1. It will be plus 2. It will be minus 1. It will be minus 2. It will come somewhere 1.58. So they are asking for which area? This area. Is it true? Is it correct?
Correct, sir.
Now we all know that
Yes, sir.
due to the symmetry, this area will be the always 0.5. This full area will be the 0.5. Okay? We have to calculate. Let's say if we'll know the value of this, what we can say, uh, we want to get that, so we have to subtract from 0.5. So what we can do? We can get 0.5 minus probability of 0 to z less than equal to 1.5. Can we do this like this? Like we can get the value of a probability from 0 to 1.58. So we will know this value. Then if we subtract from 0.5 total area to this one, so we'll get this value.
Yes.
Okay. So now we want to get the value of z value at 1.58. Just 1 minute.
0.94295.
0.4429. I will show you the table of also. We have the table, that is the table here. What they have given, we want to get 1.58. So we will go, this is the z value, this is the z value we have. We'll go 1.5, then we have to go 1.58. It's in terms of percent. Wait, I'll show you another table. It's a 1.5. Is it visible, that table?
Not clear.
Yes,
You
sir.
can zoom it.
Yes, sir.
Yeah. Yeah, now it's more clear.
Okay. So they have given, just see the area is here like from minus infinity to z. In that case, they have given the, I will show you just once, 1 minute. So here we want the value from 0 to this z value only, but here what they are giving from minus infinity to z. What we'll do, we will take the value from this one, and then we are going to divide into a two part. Shall we, can we do it? We know the value 1.58. 1.58, it will come here. It will be like 0.9429. It came. So this area is from 0.9429 from here to here. Okay. This area from infinity to z. Z is equal to 1.58. Okay. So we know that we have the value, we got 0.9429. We know the value, this is 0.5. What we can do, 0.9429 minus 0.5. How much will get? 0.4429 will get. Is it correct?
Correct, sir.
Then after, what we can do, 0.5 minus 0.4429 will do, we will get the final answer of 0.057. Any doubt is there, like how I have taken the value from this table? Just see, some tables will be from, they have given the table from minus infinity to z. In this case, like one more table I have, the same table, Gaussian table only, but they are giving from minus z to z. Understand? So again we have to, you can get the value from 1.58, then you can just divide it by 2. Understood now? Is it correct that I am saying? In this case, what they are saying, like they, in this table, this is, don't worry about the 88. It's like they have multiplied with the 100 also. So don't worry about that one. Okay, they have, what they are saying, giving the percentage probability that a point lies in the within the number given. So it's minus, means minus z to z they have given. Okay, so means so in that case, plus minus z they have given like some 1.58 from this table. If we take, it's a, so if we take table, so it will be there showing somewhere around 88.59% is fully, but what we can show 0.8859. If we divide by 2, because we all know that that side and this side, due to the symmetry, what you can do, 0.4429 we can get it. So this value we can get it, and now we can keep it at this point. We will get the final answer of 0.0571. Is it correct? Is it correct, na?
Yes, sir.
Okay. We'll go to the next question. One question is there, IQ is normally distributed with mean mu 100 and standard deviation sigma is equal to 15. Then what is the question? A person with an IQ greater than 115 has a high IQ. So what is the proportion of the population has high IQs? Is it, can you just explain that this question?
So we have to draw a normal distribution curve. The mean is 100, and the question has been asked IQ more than 115. So we have to draw a line on the right side of 115, and they are asking the probability or proportion of the population who have high IQs. So the area which is right to the 115, we have to find that probability.
Yeah. Please, can anyone please try to find out? I'll wait for some 2 minutes. Huh? I will just write like what are the things that is given. It's given mu is equal to 100, sigma is equal to 15. Let's say that will be our endpoint will be the 115. So we can calculate the z x minus mu by sigma. It will be 115 minus 100 by 15. It will become 1. According to the condition, what will be there? So according to the statement, P we have to find out IQ level greater than 115. But does that mean what is that? P is equal to Z greater than 1. Is it okay? So they are asking for the probability that is greater than Z is equal to greater than 1. Again, if we draw just so let's say this one we have 0, 1, 2. So they are asking this area. Is it correct? The same way we can get, no, like last time I have told.
Answer is 0.1587.
Yeah, that is correct. So we can get P is equal to Z greater than 1, 1 minus like Z greater than or equal to 1. So it will be like, if we go to that, so it will come 0.841.
0.84.
So
0.16.
0.1587, we will say 16%. 16% of the population will be having high IQ.
So, for example, what if they have asked like what is the proportion of
What proportion of the population has
population
high
having
IQ?
less than that? Means we have to go that side.
Yeah, that's it
Yeah.
only.
For
That
example,
that
if
is
the
the
question is asked
85%.
like yeah,
Just
that will be like
yeah, reverse the case. We'll do like we have 2 or 3 more questions. We'll solve like variety of problem. Is it clear, or like we'll do one more or two more? We'll go ahead with that. Huh? Is it okay, na? We'll solve this problem. Then we'll go ahead with that sixth one. Just wait. I will solve that also. Don't worry. Just do it fast, huh? Just try. I will do also parallelly. But they're saying x is normally distributed and the mean of x is 12 and standard deviation is 4. It's like already they have given. What is the given point? Given mu is equal to 12, standard deviation is equal to 4. So we have to, like they are saying x is equal to 20, x is 20, then 12. So means we know the formula x minus mu by sigma. So let's x minus mu we have 12 by 4. But the first case, p is equal to x greater than or equal to 20. What do you mean? For that case, if we are going for the x is equal to 20, what is the z value? 20 minus 2, 12 by 4, it will
2.
become 2. So in that case, z greater than or equal to 2. What will be there? We can get 0.5, or either we'll do like directly 1 minus 0.5 minus uh, p of 0 to z till 2, or either we can write 1 minus p of Z greater than, less than 2. Is it correct? Both are correct, na? It's like a Z, they are taking from the minus infinity to Z directly. Both are equivalent, na? Or having doubt?
Yes, sir.
So we'll go with that. So if we go to the table, so you will get the value for this like 0.4772. Is it correct? Point 0.0288. If we draw the so Z is equal to 0, 1, 2. So they are asking for this one, this area. Okay. So this is the answer for first one. I will add slides one. But in second case, anyone can tell. Second case is that P is equal to X less than 20. That is correct? Is it that one, Malina? What will the answer for that? What will be that answer? 1 minus P of X greater than 20, or either Y to go directly, we can P of Z less than 2. So it will be, they will give the from the Z is equal to 0 minus 20, so it will be like 0.9972. That both are equivalent only. Okay, na? Then third one, they are asking for the P 0 to 12 only. So for the X is equal to 12, what will the Z value? So 12 minus 12 by 4. What came? It will become 0.
0. This 0.5 then.
For the Z is equal to 0, what is the area?
0.5, right?
Yeah. So for that case, that P is equal to Z equal to 0, it will become. What about the second case? They have one more question is there. Just 1 minute.
So if we want to do this in Excel, can you show us like how we can do this?
Excel, we can do it, but I'm not too much fluent with the Excel. So if you want, then I will send some video, because I am
Okay.
working on that some origin software. Is it okay? Like in the next class, I'll make like some sort of like playlist if you want. Otherwise, you just search on that YouTube how to do that Poisson distribution, that normal distribution, that problem in that Excel. You will get it. Okay, now. But in the third case, anyone can solve this one. Like they have given the Z value only, and now they're asking for the X. Anyone? Shall I solve?
Okay, solve it.
Okay. But they have told like P of X greater than X1, for that value they have given 0.24. So means they have given the Z value. Okay, what do you mean? Like Z, Z1, they have given the 0.24. For that, like say z is equal to x bar minus 12 we were having by 4, so we'll say z1. So this one the case. Now they are saying like z is equal to, so now if we get 0 to z z1, so what will be there? We know that now we have not taken from the fully, like fully means from minus infinity to plus infinity. So we have taken from the 0 to z1. So we know that we have total area 1, but this is the 0.5. Okay, for z is equal to 0. Now they are saying like if we want to get like we know that total area will be your 0.5 only. So they know the area will be that 0 to this area they have told 0.24 are there. So this area will be the automatically 0.26. Is it correct? Now we'll go to the from normal table. Then we can get the value of z. Shall I show you the table or shall I give the directly answer? If you go through the table, so you will get a 0.71. That is the approx value. Okay. And then we will go one more slides I will take. Then we'll, so now we have the value for x bar minus 12 by 4 is equal to 0.71. Okay. So now you can calculate the x bar. 12 plus 4 into 0.71. What came? 14.84. Is it correct? We'll go to the next question. Next question, what is that? The mean yield for the 1 acre plot is 662 kilo. What do you mean? Like they have given the mean value for the particular.
Sir, can you show the last slide first one? Yes.
This one.
And another second
Yeah.
last. Thanks.
Okay, so they have given the mean yield for 1 acre plot, like means they have given the value of given, we'll write mu is equal to 662 kilo. What is the standard deviation? 32. Assuming normal distribution. Okay. A normal distribution. How many acre plot in a batch of 1000 plots? Just leave this part, like we'll assume n is equal to 1000 plot. Would you expect to have a yield over first condition? First condition over 700 kilo. Second will be the below 650 kilo. Third is the what is the lowest yield of the best 100 plot. It will be like greater than over greater than 700. In that less than 650. In that they have told like out of 100 plots, like then what is the lowest yield value? Means they have they'll be giving some value. Then according to that we have to find out the yield value. Okay. So first we will calculate for the first case. What is that? The probability that a plot has yield 700 kilo. Okay, means they didn't told at least 700 kilo, means it's like a over 700 kilo, means there will not, so it will be like p is equal to x greater than 700 kilo. So if we calculate the z for this particular x minus mu pi sigma, what is this? 700 minus 662. What will come? 1.19. Then after, like they are saying to calculate p is equal to x greater than 700, या फिर इसको लिख सकते हैं, या फिर either we can write x greater than 1, not 1, is not like this, 1.19.
Z, it is Z.
What? Z, sorry,
Z.
yeah, z. Then after, how we can write again? 0.5 minus p is equal to 0 to z 1.9. Is it correct? Same way we can see the table, so it will come 0.3830. So it will, final answer will be the 1170. Hence, in a batch of how much plot? 1000 plot. The expected number of plot with yield over 700 kilo will be 1000 multiplied by 0.1170. How much it came? 117. Is it okay? The second question, what they are saying, like it's a less than 600, required number how much? P is equal to less than 650. Is it correct? Then we'll get 650 minus 662 by sigma. How much we'll get? Minus 38. Is it correct?
Yes,
So then
yes.
we can get z is equal to less than 650. Oh, sorry. Minus of 0.38. If we change, multiply with the minus, so their sign is going to change. Is it correct? Once this is the inequality sign, when we are applying any negative multiplication, so the sign is going to change. Or any doubt is there in this part, like that how this sign got changed to this sign? Because here we have the minus. Once you applied with the minus, the sign is going to change. Is it correct now?
Can you little explain, sir, actually, how it is?
It's a inequality. One concept might have you have seen in first year of graduation, or either not first year, we can say it's a 12th or 11th part only. Inequality problem. Yeah, let's say we have that minus of 5. So if we multiply with the minus, so that sign is going to be changed, then it will become 5. Okay.
Okay, sir.
So this concepts of basic concepts are there. So now it will become again a last like problem point. 0.5 minus p of 0 to z of 0.38. 0.5 minus, what is the one? It will become 0.352. Is it correct? Now we can multiply with 1000 because we need for 1000 plots. 0.352. So final answer will be the 352. Is it okay?
Okay, sir.
So now we have done with second problem. What is the third problem? Anyone? Third is saying that lowest yield of the best 100 plots means they have given the probability also. Probability means Z value they have given. How much? Out of 1000, there is 100 plots will be there. Means 100 plots they are going to be yield out. What they have given? The lowest yield. Let's say X of the best 100 plot. What do you mean? P of x greater than x1 is equal to 100 by 1000. What will become? 0.1%. So now let's say Z is equal to x minus mu by sigma. Now we'll say x1 minus or either x minus 662 by 32 is equal to Z1. So for Z greater than Z1, that value we have given. So means till this value we have given. So for the last time 0 to, if you want to get Z2 Z1, so it will become 0.5 minus 0.1. So it will become 0.4. So if we are going to see for the value of 0.4, you will get to the value like 1.128 from table. And if we are going to keep this value 1.28 into x1 minus 662 by 32, you will get a x1 answer. Okay. We'll go this question, we'll see next time maybe. Or what about this one, a statistical test? What do you mean by statistical test? Why we are doing the statistical test? Anyone please? Now we have finished with the that is a probability distribution. Now we'll go the next part. We have the statistical test. In the statistical test, we'll be having t-test, f-test, chi-square test, f-test. Why we are doing the testing actually? Can anyone please answer that one?
Comparison of different treatments or distribution of certain characteristics among different population.
Okay, that is also correct. Anyone? Some more I'm expecting.
To check any hypothesis.
Yeah, to check with the hypothesis, or either we want to conclude something. Conclusion we want to make.
A single test is not suitable for all kinds of analysis and studies. So we
Yeah.
need different types of tests. So for
Yeah.
example, the F test is suitable for kind of variance, and chi-square test is suitable for ratios. So different types of variables, they require different tests.
Yeah, it's like a testing. Why we are doing the testing? Testing we are doing like to make the conclusion. Let's say we have a different number of samples are there. If the number of samples is less, so we can apply the different test. If the number of samples are more, so we'll apply different test. If we have in the forms of variance or the ratios and all the things, we will apply for different test. These are the all tests that can be applied. But we are doing the testing to make the conclusion, like whether whatever we are going to assume, like whether that okay, I'll say that drug is going to be that much efficient. So we will assume like, okay, this drug is efficient. We will assume it and then we'll go for the testing. If it is not came, so we'll say, okay, no, this the testing not coming good, so we are going to reject the null hypothesis. Okay, so is it like it's like we want to make the conclusion based upon the data that is already available. So with a single test we can't justify that optimized the conclusion we can't make. So for different types of data we have to take a different types of testing. So in that, so what are the things that can be required for the testing? First one is the sampling. Sampling means, what do you mean by sampling? It's already I wrote, but just tell me in terms of any application. Let's say,
So while selecting the data, there should be no bias and all. So we have different kinds of sampling, different based on different studies.
yeah, let's
So
say
that
like, yeah, yeah, go ahead.
continue.
Okay. The sampling we are saying like we have a like a number of datas are there, like number of samples that populations are there. We will take a sample from that. We can't do the testing for all. Let's say for any industry or either any medicines are there, like we are making some paracetamol or some drugs we are doing, but we can't do the testing for the all. What we'll do? We'll take the sample for the particular, maybe in terms of number. Okay. So population then sampling. So it's a subset of a statistical individual in a population is called a sample. The number of individuals in a sample called the sample size. Is it correct? This line is correct now?
Yes, sir.
Then after that we can take the sampling in a different perspective based upon our need or either that certain conditions and scenario. We can take the that purposive sampling, random sampling, then stratified sampling, or either systematic sampling. Everyone have their own objective and then that motive for that sampling part. Okay, so purposive sampling, why? Sample units are selected with the definite purpose of view. It's like a, let's say we are doing some sophisticated like testing we are doing. Let's say if anyone is working in some sort of critical medicines or critical drugs are there, that we can't make in a volume production. Is it correct now?
Yeah.
So that cannot be done in like mass production. So if we are going for some critical drugs and all the things, or either I'll say if in mechanical point of view. So let's say that is the aerospace part, or the airlines are there. That is a sophisticated objects are there. For that we do this purposive sampling, because the cost of sampling again it will take time. It will take the cost, time, and all these things. So for that part, so based upon the our requirement, we'll go for the purposive sampling. Random sampling means, let's say we have a some population, like we have a one village are there. We are giving that administrating the drug for the polio. So like we are going to administer, that's okay. But if we want to take the samples from them and then we want to check the validity or either the efficiency of the drug and all the things, so we will take a bunch of some samples from there, from some sample from there. So it's not going to be selected, so it's going to be a unbiased. We will not do the biased, okay, we will take this much or this batch number of drug, this batch number of drug, or either we will take this particular drug. So it's like a, we will take a random sampling. So we will, it's like a, there will be an equal chance of that is going to be all included. Okay. Then after stratified, anyone can explain with the term only? Stratified.
We will make the data into different groups.
Okay, it's like a, we are doing the classification. Is it correct?
Yeah, strata.
Yeah, it's like a, we are doing the classification. Let's say, what is the example of that? Can anyone say? When we are going to do the classification, and why is it required? Why it will required? It's because of that our application part. Where we can do any application, can you tell? Let's say we have like we are doing. Let's say we have a population that consists of male and female. Is it correct that we can classify in the two terms, like one will be the gender male and gender that is the female? It is correct for the stratified that stratified sampling. Up to some extent that will be correct. If the
Age-wise strata you can make.
yes, ma'am. Age wise we can also do. Then after we can uh, do based upon the training level also. Let's say we have a my work is somewhere around the athletes I am dealing with that. So in that we will not having number of people will be not too much, but we will say that based upon the training level, or either based upon we'll say the age group, or either we'll say based upon the weight. So it's like we are just classify within the population itself. Is it correct?
Yes, sir. Yes.
Okay. Then after last will be the systematic sampling. There will be numerous sampling are there, but this is a sampling that frequently that will used in the our that biostatistic or either in our physical science program. That is systematic sampling. It's like we are going to not take the random sampling or stratify like it's a not the, it's like we totally different from the that is other sampling. You will take it in a systematic manner. If you say I will be going with this, let's say we have a 10 age group, so we will not will take from the one from that first age group, then will go direct to the 7 to 8 seventh one or eighth one will not go. If we are in the first age group, so we have to do all the sampling from the systematic like first age group only. Once we finish this part only, then we'll go for the second age group, then third, then fourth, then five. So it's like a systematically we are going to do. Okay. Can anyone tell the difference between the purposive sampling and the systematic sampling? Because it seems same. Some sort of difference will be there. Anyone? Anyone have the idea? There is like a systematic again. It will be like we are just classification doing, or purposive means it's like we have already set defined goal. Okay, already we have set the goals, or either we have a already the objectives are clear. But systematic also we have the clear. But the thing is like within the purpose we are going to divide many that group or anything. So it's like a just sort of systematically we have to go. We can't take from the randomly from the anywhere. Just 1 minute. So once it will do the significance, so we have to know that whether what is the test of significance. Okay, what do you mean by test of significance? Anyone, please? Actually, this is a test of significance itself, a very important that is an aspect in the sampling theory. That will be the study of test of significance, which enables us to decide on the basis of the sample result. What do you mean? The like division between the observed sample statistic and the hypothetical parameter value. It's like a whatever the exact value we have got from the statistic, and then whatever we have assumed. So they are going to say whether they are going to be like we have taken the hypothetical that's correct or wrong. We have to whether we have to accept or whether we have to reject it. Then second one they will say the deviation between the two independent sample statistic also. Is it correct? Like they are going to like test of significance. It's like they will be going to say, or they will be enable us to decide or either to make the conclusion based upon the deviation we will get, or either like we can make the conclusion based upon the whether how much deviations are there already. I think that will be better when I'll be taking the session. So I'll keep open for all. Once it will get, we will go, then we'll keep on like control. That will be better, I think. Then after in that test of significance, we have the null hypothesis. Null hypothesis means anyone what is the null hypothesis?
This initially hypothesis is done, that is actually typically done opposite to the expected.
Yeah, like whenever we'll say like any population having the what we can say cancer or either anything, so we'll say okay that is the null hypothesis. We are going to say that is true only. Always we'll say true. So that is the null hypothesis. It's like a null. What is that alternative hypothesis? It's like a complementary to the null hypothesis. Whatever we have told, assumed that is supposed to be wrong or something, or either that is so that is the alternative. So it's like in that case also we will be having two-tailed or one-tailed, right-tailed and then left-tailed. Anyone know that what is the difference, where we are getting difference between a two-tailed and then right-tailed and left-tailed? Anyone?
So two-tail means we do not know exactly the what is matlab mu is greater than mu zero or mu is less than mu zero. We do not know which way the direction is going. And one tail means either which we are checking the mu is less than mu zero
Or either
or
can,
either the mu is more than mu zero.
yeah. So if it is that right side, so we'll say the right-tailed. If that is the left, so we'll say the left-tailed. Is it correct? So whenever we'll go for the statistic, any testing, so there is some sort of basics are there that we need to be very clear. Then after we can apply all the test. So that's why what I feel like before starting to the session, that exact session for that question solving, I just want to give the brief. Some of this topic might have you have went through the lecture, you have seen that. Is it there that I have went? Some part is there. Then after, what type of error will be there in the sampling? Usually we'll say like there will be a two type of error will be there, type 1 error and then type 2 error. Can anyone explain with with example, like we are saying that reject HO, that is the null hypothesis when it is true. So that is the type 1 error. So what is the real life example for that? We'll say like we have some product. Someone was saying, can please go ahead.
It's like if we are comparing two drugs and then we have kept null hypothesis like both the drugs are having same efficacy. But when we are doing significant test and
Test.
when we are checking probability and when we are accepting the alternate hypothesis and then
Okay.
we are rejecting this null hypothesis. So we are saying that one drug is better than another drug, but basically both the drugs are same. So at that time the which error is that error is known as type 1 error or alpha
Yes,
error.
ma'am. Yeah. Second one is the beta error.
Yes, second one is beta.
So type 2 error. So in that case, we are going to accept the null hypothesis, but it was already wrong. So it's just become the reverse case. Okay. So what is the meaning of level of significance and then critical reason? And then there will be of critical reason. We are saying the reason of rejection also. What do you mean by level of significance when we are saying that level of that 5% of level of significance or either 1% of the level of significance? Is it complement that level of significance is complement with the confidence interval?
Confidence interval, yeah.
Yeah, yeah. Both are complementing each other. So level of significance, it's like when we're saying 1%. So means 99% of the time that whatever we have testing, so that is correct. Then 1% of time like it is going to fail it out. Is it correct, na? That whatever the terms I'm saying.
Yes, sir.
If just say sometime what will happen in the question itself, they will say 95% of the confidence interval, or either they will say 5% of the level of significance. So if in the question, if it is not given like 95% or either that 99%, so you have to automatically assume that that is a 5% of level of significance. And then one area is there, that critical reason. Critical reason means that is the region of rejection. What do you mean by the region of rejection? Means when we are saying like null hypothesis, maybe, or either we are saying that our 5% of the product is going to be a fail. So means that whatever that outside result, there is a one terms are there. This, so this is the lower critical value. This is the upper critical value. So after this Z alpha, it's going to be a rejection region. It's going to be a Z alpha rejection region for the this is a two-tailed test. For right tail test in the right side, for the left tail test it will be the left side. Okay, so this area we are saying rejection region or either critical region. So in that one tail test, like we'll go, okay, first always will be like your that null hypothesis that we are going to assume mu is equal to mu naught always. That terms will be changed sometimes if in terms of population, so that is going to p is equal to p naught. If in terms of sample itself, so s is equal to s naught. So don't worry about that word. Then we'll take the alternative hypothesis for the right tail will be mu greater than mu naught. Okay. Then after for left tail, that will be mu less than mu naught. So as a test of that is the statistical hypothesis where the alternative hypothesis is two-tailed. So for that null hypothesis will be mu is equal to mu naught. Second will be the alternative hypothesis that is H1, that will be the mu is not equal to mu naught. So that may be either, we are not sure whether that is going to be a greater than or either less than. So in that case we will say two-tailed test. So in that critical region is given by the portion of the area lying in the both the tails of the that is probability curve of the test statistic. Okay. So this is how it looked like when we will say for the level of significance alpha. And usually in our test we are dealing with the level of significance alpha only. We will not go over the beta value. Whenever you will see any table like a Fisher test table or either normal test or anything, so they will be giving in terms of level of significance alpha only. Is it correct? Huh? Like we are not supposed to be enter in the type 2 error. For type 2 error we will be having some different set of that methodology. Okay. So for two-tailed test, let's say for at a alpha significance level, so this is the minus z alpha, then z alpha. So right side and then left side will be the rejection region. Then after for the right tail, it will be the right side of the z alpha, it will be the rejection region. For left tail test, it will be the left side of the z alpha, it will be the rejection test. Some of the values they have given for the critical value of alpha for the 5% of level of significance, and for 1%, for 10%, for two tail z alpha will be 2.5%, for 2.58, for 5% 1.96, for 10% 1.645. For right tail it will again change, for left tail again it will change. Just say for right and left it's just a change in sign itself. Okay. So what is the procedure? What is the procedure? We can summarize below the various steps in the testing of a statistical hypothesis in a schematic manner. So now we have given some grounds for the how we can do the testing. So now we can summarize. Then from that point, from this point, we can go for the any testing part. So first will be the first we have to set up the null hypothesis. What is that? H naught. That will be the mu is equal to mu naught or either whatever the it will come like in terms of population or either in terms of summation. Yes. Then after we have to define alternative hypothesis. Is it correct? Then we will go for the then we are going to decide whether that is the which tail we have to use, whether that right tailed or either left tailed or either two tailed test. So based upon the condition that is given in the question, we have to decide. So once we will set up with the null hypothesis, alternative hypothesis, then we'll define the level of significance. If in the question it's already mentioned, so we have to go for the what we can say that particular level of significance. Otherwise, if it is not given in the question, so you have to what you have to do, like you have to set the 95% of the level of significance. Then after we are going to apply the statistic formula, like standard error formula. What is that? Anyone have the idea like what is the standard error formula? Sampling, like when we are doing, so we have to mean sigma upon root under n something. So we will apply the statistical sampling. Like we will use some to get that for large number of population. There will be some different t value will be there, z value will be there. So once you will get to know that, so you will get to know the t value. Then we have assumed the null hypothesis and then alternative hypothesis. Based upon that, we are going to make the conclusion. Just like this is the test of significance of a large sample. Just leave that. So we have the statistic and then expected error. We have some formula. This part you can go to the book of that I have told, like Kapoor, VC Gupta and VK Kapoor. That all the things that will be there. Okay. So once you will get to know this all parameter and all these things, so what will happen? So you can go for the any testing. So can anyone tell, like now we'll be just today I will brief about the t-test. Anyone have the idea about the t-test? Where can be applied? What is the condition for that t-test? If anyone
T
have
T-test, there are two types, isn't it? So one is independent groups. So we apply unpaired t-test.
okay,
And for when we are seeing some change uh, before and after, then we in the same group, then it would be paired t-test.
okay. So before starting with the
T-test will basically compare, use for comparison of means, I
okay,
think.
uh,
Yes,
yeah, it's
yes,
like
it
a
compares
means
means,
only.
and yeah, and it is
So that t-test can be done for that significance of the mean for the random sample. Then second will be your will be having that if the number of sample is less, like 30, less than 30. I have seen one comment that is a for no for more sample size we have to go for the another test, like maybe the P and then F test. For the t-test we need to go for the what you can say like if we have the number of sample less than 30. So what is the condition? So that is sample size should be small. Okay. Second one, the population standard deviation should be known. It's like sometimes we'll say that student t distribution. Like when we speak about the teachers, before said we should know about the some distributions also. So it came from the student t distribution. What is the condition for that? That for that we have to, like, a number of samples should be the less than 30. Second will be their standard deviation should be known. But the third case, so that should be a normally distributed. Okay. So what is the first case? That to test the significance of the mean of the random sample. Then second will be your this content. Second will be the to test significance of the difference of the mean. It's like we are dealing about the only mean itself. Shall we do one question based upon that? To test significance of the difference between the mean of two sample. Then third one will be the, that will the first one was the dependent, then second will be the independent, then fourth one to test significance of the an observed sample correlation coefficient. Okay. So it's a more or less like today for as of now, like we'll wind up the session here. Like if anyone have the doubt, then we'll discuss. Any queries are there?
Sir,
Yeah.
can you share the questions that we solved today, the for us to practice?
Yeah, sure. I will. How can I share you with, like, you anyone, please? Can you tell me your email ID so that I will tell you, send you.
Yeah,
Can you
it is shrutibide@km.edu. SHRUTI
just 1 minute? SHRUTI
BHIDE, B for Bombay,
B for Bombay, HID
HID for Delhi,
D for Delhi,
E,
E
yeah, at km.edu.
at
Shrutibide@km.edu. My name is reflected over
yeah, yeah, sure. That at the rate km dot
dot
edu.
edu.
Okay, okay, edu.
Sir, will you please share for everyone if it is possible?
Yeah,
Mm,
I think so, sir.
that will be better, I think.
Yes, sir. It will
We
be
have
better.
shared our email addresses.
Yeah, I will share my own email ID. Either shall I send my personal or that college one?
Everyone.
Sir, I think you can attach this file in the mail where we are getting the link. Then I think everybody can.
No, actually, that link you are getting there from the NPTEL team. We are not supposed to.
Okay, okay.
One thing you can do, like you can write the mail to me because I'm not sure. I will just put my mail, just ping me.
Okay, okay. Oh, yes, sir.
Yeah, you can just ping me if that is possible. And I will suggest you to go through that one book that VC Kapoor and then VK Gupta, that VC Gupta and VK Kapoor. And some question or anything, any doubt will be there, then I'm here. You can ask.
Sir, your email ID, one more time. I could not see the email ID. Your email ID.
razasjad.ar@gmail.com. Yeah.
So I have a question. I have received an email that there is another session tomorrow afternoon as well. Will it be the same session or is it a different problem solving session?
The same motive will be same, but the content will be somewhat different. Sometimes it will be same also, that we are not in touch with them. Actually the number of students have registered more, so that's why two sessions are there. If someone is not able to attend today, so they can join another day.
Okay, sir. Thank you.
Sir, I
Anyone?
have one query regarding assignment 2 first question. Can I ask?
Yeah, just ask.
Sir, the question is very easy, but I could not find any options, right? Because it was asking like in mean was 12 centimeter, standard deviation 1 centimeter. And the question was how many moles will have confidence interval around 95.4% limit.
Okay, so it's like they
I
have.
found
I had the same question. I tried to solve it. I could not solve that.
because I don't find any proper option, or rather, we are wrong. I don't know.
Yeah, even
Because
I didn't.
my answer is confidence interval is 10 to 14, and the option were not given like that.
Is it this one? Mean diameter,
First
something is there.
one, yes, 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 this first one.
That mean diameter of the tube are 20 centimeter. Then standard deviations are there. So they're asking for the diameter for that 95% of for the bolt.
Okay, so I just calculated Z 95.4 means plus or
Uh,
minus 2 SD.
yeah,
We took directly like that. Okay, that
uh,
is the mistake we come.
yeah,
Sir, can you do just full screen for that?
yeah.
Thank you, sir.
We're not supposed to.
Thank you, sir.
Thank you.
Okay, anything is there? Any doubt? Like we'll have some 5 minutes more. Will Ma'am Archana Reddy, she has raised the hand. Can you? What is the doubt? You can ask. How is the session? Can anyone give the feedback? Because so that I can improve for the next session.
It's good, sir.
Okay, thank you. Then any
Sir,
like
it
two.
is good because I have tried multiple options to get to know biostatistics because I have been in this pharmacology field for so long. And yes, of course, you have kept it crisp, but the basics we need to know before we take this up. That is very sure.
Okay, man. That's why, like that means I'm trying to clear the basics so that you can solve any type of any type of questions. Like if I'll be solving directly, so might be you will not able to get the concept like from where I'm taking.
So you are making our concepts clear. That is very true. Thank you, sir.
Okay.
Sir, in exams, how can we get those tables?
In exam, I didn't get you.
How can we get those tables? The tables will be supplied to us or the value will be supplied?
I think it will be already in because the exam will be your online mode in at any center, so it will be already there. If they are asking, so in the question itself they will give.
Okay.
Regarding this assignment 2, there is some concern, like a few questions are like confusing. Can we
Okay.
get some help from you regarding that, or we have to do ourselves only? I am not sure.
You have to do by yourself because we're not supposed to explain the question because the thing what happened in the last class that first assignment and then what I solve in the session it was same and we got the mail for that like we didn't got the mail, we wrote the mail like both are same, so they told okay you can create your own assignment, you can solve it. So please sorry for that. If you have the doubt you can just ping me, I will just get to know and then I will explain the concept how that will can be happen.
Okay, okay.
So shall we wind up the session?
Yes, sir.
Yes, sir. Yes, sir. Thank you, sir.
Okay, thank you. You can leave now.
Thank you.
Thank you, sir.
Thank you so much.